Chapter 22, Example 3. Below are the saturated fat content for several pizzas sold by two national chains. Is the saturated fat content different between the brands? So we're going to assume that the companies of pizzas are independent of each other. We're going to do a two-sample test. Let mu of D, so mu of brand D, be the mean saturated fat content in brand D. Let mu Pj equal the mean saturated fat content in brand Pj. So now let's write our hypotheses. H naught mu D minus mu Pj equals 0. So in context, we're saying the mean between the two is 0. There's no difference. HA is mu of D minus mu Pj does not equal 0. So we're simply saying there is a difference between them. The null is that there's not. The alternative is that there is. So when we make our normal curve, we have 0 in the middle. It's two-tailed. We're shading on both sides. Assuming it is normal, so we need to check our conditions first. Let's look at the normal probability plot for brand D. If you notice, it's very straight, fits the line well. For brand PJ, same thing. It's pretty straight, pretty linear. The points are close to the line. It looks good. No real pattern there. So now we're ready to check the conditions. The two samples were chosen independently of each other. Since there is no mention of randomness, we will assume the pizzas are representative of all pizzas from their respective brands. The normal probability plots of both brands roughly fit a line with no obvious outliers, no points off the line, there's no pattern to it. So it is safe to consider the distributions approximately normal. I will use a student's t-model to perform a two-sample t-test. So we have all this in the calculator. You saw both columns there. We're going to go to calculator page. We're going to statistics, stat tests. We're doing a two-sample t-test, just as we stated. This time we're using data that was already entered in the calculator. So list 1 is brand D. List 2 is brand PJ. You have to put these in order. List 1 has to be what comes first in your hypothesis. Don't worry about the frequency. Alternative hypothesis is that they are not equal. Do not do pooled. So we hit OK, and there's all our data. T is 4.823. P-value is 0.000032 with 32.757 degrees of freedom. So we're going to record all these statistics. XD equals 11.25. X of PJ equals 6.53. The sample size for D equals 20, and the sample size for brand PJ equals 15. Our standard deviation for brand D equals 3.19, and our standard deviation for brand PJ was 2.588. So our degrees of freedom were 32.757. Our t-value was 4.823. And we had a p-value of 0.000032. That's exceptionally low. The p-value of 0.000032 is very low. So I will reject the null hypothesis. There is evidence to suggest that there is a difference in the saturated fat content between the two brands. Since we rejected the null hypothesis, we like to do a 95% confidence interval to get a feel for what the real value might be. According to a student's t-model, with 32.76 degrees of freedom, I am 95% confident that the mean saturated fat content of brand D is between 2.73 and 6.71 grams greater than that of brand PJ. And so we got all that information from the calculator. Let it do the work for you.